All right, good morning, everybody. Hope everybody had a great weekend and enjoyed the day off and took a little look at the world around them yesterday on Martin Luther King Day. I think that is an important thing to look at, how we've made progress. There's still a lot of progress to go in terms of equality. So one of the things that I did notice is there were some people that did not post on the discussion boards for week one. If you are one of those, please post as soon as possible, and I will pretend that I forgot that that was actually due Sunday night. So please make sure you've posted on the week one discussion board. Week two, so the week that's going to end this Sunday, I have another question that we're asking. So all throughout this, you're going to see lots of different versions. So when we're inside of Cengage, you see one version of Python, and some of the book shows like a 3.7. When we go and install in a couple of weeks, you're going to see that we're going to look at, there's version 3.8, 3.9 out there. All these different versions come out. So why would we want to install the latest version? So make sure that you respond, and I'm going to try to send out some email prompts on this because it seems like a lot of people didn't respond to that. So somewhere up here, there it is. So I went through a little piece of this and we looked at how does that computer store memory. We looked at the terms bits and bytes. So a bit is a single 0, 1, byte is 8 of those strung together. So this is really kind of the way that our process works. And inside of Cengage, it's a little different because we don't see some of these processes, but we will fairly shortly. So typically we use a text editor, and there are a variety of text editors we can use. Python is really nice because we aren't locked into one specific model of text editor or anything. We can use anything from Emacs to Vim. You could even use something like Word, but it would be painful at best. Word adds a lot of extra things. What we're really looking for is things like Notepad, something that's just a pure text application. And that's all Python really is a text file. So that makes it really nice. So our translator then, or our Python system, comes in and says, all right, we're going to take this code that you wrote in a text editor, I'm going to translate it, and then I'm going to run it. So at that time, then we get these user inputs, we get program outputs, and we may see things like an error message. Hopefully not, but we may see those. So this one language we're doing is called an interpreted language. In other words, it reads it and runs it and converts it into machine code on the fly. So there's a slight difference between that and something like a compiled language, and we'll get to some of those differences. So this is just a really quick timeline. Computers haven't been around that long, but the idea of programming has been, because even before 1800, we wrote algorithms. In other words, solutions for a problem. So we get up here to, newer and newer optical storage, the World Wide Web. Things have changed around us a lot. And now we've got all these things like social networking. We have people playing TikTok and Facebook and everything. So I'm not going to go into a great detail, but the abacus is kind of interesting. If you've ever seen anybody use one, it's actually a really effective tool. So this is a couple of things that pushed it. The Census Bureau was one of the things that happened. So every 10 years, we take a census. And so these tools that we use come a lot from these pushes. So Dr. Turing wrote some things, and we still talk about, can it pass the Turing test? In other words, can my code simulate what a human being would do? Can I tell the difference? You're going to see this term called Boolean logic. That idea of how we're going to write questions and form answers. So way back when in the 40s, mainframe computers would take up a room this size. It would take an entire power plant to run them, and now you have more power than that inside of your calculator, inside of your computer, inside of your phone in most cases. So, couple of high-level languages that kind of came out originally. So the first programming languages, you literally were entering in those zeros and ones. As we got higher and higher level languages, we came out with Fortran, which is still in use, formula translation, Lisp, COBOL. As we got faster, we got rid of the vacuum tubes. And then once we came out with the integrated circuits, there was an event that was kind of interesting. So Gordon Moore, who was part of Intel, said this is what we expect. And he wrote something that's called Moore's Law. Now, it's not a typical law like you would find in science where that means it's absolute and there can't be anything going wrong. It's an idea. And that idea says that approximately every 18 months, we're going to double the ability of our hardware and software. What he actually wrote was there'll be more transistors on a circuit, but the same idea holds true that every 18 months, and really, we have actually maintained that until this date, which is frightening. So, a couple of other things. This idea of a screen display didn't come about until 1960s, where you could actually put different pieces on it other than just text. In the 80s, Microsoft came about. That was one of the things that happened. And in the middle 70s, early 80s is something called ARPANET, which is where we developed the internet from. So I think that's kind of important. Tim Berners-Lee at CERN created what we call the World Wide Web. There was an internet before that, but it wasn't graphical. It was all text-based. So the idea that now we're having these links to different things and it's a graphical component. So we started to develop web browsers. So that happened. Client-server apps. And then along came these people named Brandon Page. And they had an idea about searching the web. Because before they came along, there really wasn't an easy way to find information that was already out there. And so they developed some technology for searching and indexing. So those are the founders, of course, of Google. Wouldn't you have liked to have been on board at Google when they first started? Because those people made a ton of money. So we then moved into, we still weren't all connected, but we moved into this idea of personal digital assistants. And I remember these, and they were great, except I wasn't connected to anything. So they were there. It's kind of like a phone, but without a phone connection at that point. So Apple's created some things that were revolutionary. The iPad, the iPhone certainly has taken over the world. And now this idea of social networking has changed a lot of things. The world is different than it was before we had social media. And I know a lot of you guys grew up with social media, but it really has changed how we interact with people. And then in the middle of the 90s, we developed a Python language. All right. That's kind of where we're going to leave. We're not going to do a history lesson on everything, but Python.org is our authoritative site for everything Python. And if you go there, which I expect you will many, many times, there is everything about Python you could ever want to know. So, success stories, people that have used Python, this community. So everything from forums to stories to merchandise, everything's listed in here. There's documentation. Look at that, a beginner's guide even. So there's all different kinds. Everything we want to know about Python is here. Here we can download Python and run it, and notice the latest version is 3.10 now. Oh, and now they made a few changes. Python 3.9 Plus cannot be used on Windows 7 or earlier. Well, that's certainly going to affect us. So there's all different kinds of things, including if I want to get a job. So maybe I think, all right, I want to find a job. I like Python that much. So here's a job in the United States, a Python developer. There's one in Amsterdam. So some of these will tell you they'll telecommute, software engineer, remote in the United States. So some of these will actually tell you some salaries and everything, but some aren't. So there is a ton of jobs and things available in here. So this site is kind of our holy grail of everything Python. So everything you could ever want to know, hiding right up here. So everywhere from people in the community. So there's actually some, like PyCon last year. We'll see what happens this year with Corona again in the forefront. But there's conferences. There's all different kinds of things. So that is our authoritative site for everything Python. So again, Python is an interpreted language. In other words, we run it as we type it. It interprets that and it goes. So we've looked a little bit about in the shell, but inside of Cengage. So we're going to cover that next week, how we're going to install Python. So the shell is really great for short little code. So this little Python shell like that, where we have the arrows pointing, that one's really handy. But for short items. So once we get bigger, we're going to show you how we can actually do them in a much longer program. So here, for example, hit the wrong mouse. So here we're going to print something. And remember, all of these are functions. So a print has to have those parentheses. And we're going to print something. Now, if I already have a variable name, I can use it. In this case, I put it in quotes to say, hey, I want you to print this item. So this one says, I'm going to take input, I'm going to put my name in, and it's going to shove it to the left in the name. So the hardest thing to remember, I think, in here is that equal sign isn't really an equals. It's an assignment operator. It says everything on the right gets shoved over to the variable name on the left. So the input takes whatever we type in and builds what we call a string or a text input and sends it back into the program. If I'm going to maneuver that as a number, again, we have to use these conventions here for either integers or float. Now, this is where Python is really nice because there's only a couple of different types of numbers. So integers are whole numbers. The advantage to an integer is it's quicker to maneuver. It's shorter, it's smaller. And there's a lot of things. If I'm counting to 10 or 100 or somewhere where I don't need a decimal, it makes a lot of sense to use an integer. So the other type is called a float, and I can convert from one value to another by using these functions of integer or float to change those around. So we kind of quickly looked through that. A couple of other ones we can do. I can change it to a float. I can change it to an integer. So when you look at these things, make sure that you look at all the pieces inside of our book. So I can also do some really interesting string manipulations. So I can actually add two strings together. And I don't get a number. What I get is those two strings stuffed together. So there's some really interesting things that we can do. All right. A Python program is, for now, is all going to have the .py extension. If you are on a Mac, you may need to put that in deliberately, and I'm going to show you how to do that in a text file on our own. So when we run what we call a script or a program, we need to make sure it says .py, and we'll show you what that looks like. So here's an entire program. So this one's going to look a little different. It says myprogram.py, and here we have an input into the width. We convert it to an integer. Input the height. We convert it to an integer. Area equals width times height, and we print out that value called area. So that's a very simple program. So here it is running. So when we take our code, we first check for syntax errors. So in other words, missing words, missing commands, variables, and then we actually try to run that code as it converts it into bytes. So a syntax error. So here we have length, L-E-N-T-H, because we didn't spell this correctly. And that's one of the most common things. It's also one of the harder ones for us to find, because when I look at this, I knew I meant to type length, and I knew I meant to type length down here, but our brain says, oh, I'm putting in the right value. So spelling errors are especially hard to find. So you're gonna see that fairly often. So that's really where we start at here in our Python for this week. So there are some assignments, and we kind of looked at a couple of them already. So our textbook, make sure you have read chapter 1. At some point when Cengage decides to load here. Come on, Cengage. Come on, Cengage. Come on, Cengage. Well, let me go into, see if I can figure out that one. Sometimes Cengage is great. Sometimes it's a pain in the butt. I will say, I don't really want to register for that right now. So, yay. All right. So, this chapter's got a lot of content in it. So, further reading summary, there's even some questions you can test yourself at the end. So if I went to those, so what is an example of an algorithm? A dictionary, a recipe, a set of instructions for putting together a utility shed, the spelling checker of a word processor. So if I were going to read that, is a dictionary an algorithm? Does it tell us how to do something? No, but I'm going to argue a recipe would be an algorithm. I'm also going to argue that a set of instructions for putting together a utility shed probably is an algorithm, but a spelling checker actually uses an algorithm, but it may not be in the same way we're thinking about it. So there's a couple questions, and if you know these, you should be able to pass the very simple first quiz that's in here for this week. All right. So we looked at some of these assignments, and we'll work on some of these as we go. So this is a practice with flashcards for terms. This is a practice creating that crossword puzzle. Terms are one of the harder things to learn, so I'm going to encourage you to use these. There's no grade on them at this point, but I encourage you to use these. So what does have a grade is this, the basics quiz. So this has a grade. These two don't, but they're a great resource to do before you take that quiz. All right, so we did 1 and 2, if I remember correctly. So let's take a look at number 3, see how quickly it will load here. So in this sandboxed environment, come on. So this is that idea of that shell again. And this again is, so initially I put a lot of these not graded to give you some experience with them so you can try those. So this will allow you to put in almost anything you want. So if I wanted to do an input, but remember that input doesn't do us a lot of good until we put a value with it. So let's say name equals input. Please enter your name. And notice in this shell, it doesn't automatically add the open and close parentheses. So different editors work slightly different, so you got to look and notice what you're doing. So this is going to say, all right, enter your name. Well, nothing exciting happened except we stored my name in a variable called name. So now if I said print, it just took my name and spit it out 5 times, all shoved together. Interesting. Or if I just wanted it my name, so it stored that value in there. And when I used the multiply key, it didn't change that to a value. It said, all right, I see what you want. You want 5 copies of that all in there. So this one is just kind of an experiment. It's a great place to try things in here. You cannot, and I repeat, you cannot break anything in here. So if I want to say, what is define? And okay, that's not going to work. So you can try all different kinds of things. Nothing's going to help or hurt it here. So if I type help, and I'm looking at an object, so help print, that's also a function. Notice we took in a name, and it will actually say, all right, here's a print, here's some items about it, optional arguments, but that's not very easy to use, I don't think. So maybe instead I come over here to Python, I search for print, and make a print function. All right, so there's all kinds of information in here about different prints and different pieces. So I may even go, well, that's not what I want. Let me look at the beginner's guide. Maybe the beginner's guide will help me here. So I can scroll through and take a look here at the beginner's guides to the different pieces and probably find out a little more. It's handy. It's handy to have those functions, but they're usually not very user-friendly. So, all right. So that is 1-3. Yeah. So let's take a look at 1-4. All right. This one is a graded assignment. So this one we have a couple of more things happen. Because notice here we're creating a program called rectangle.py. Here's you have your terminal output, and in fact down here you have a button called Run Code. So if I run this right now, nothing happens, or at least nothing you see. But I can test that. I can say print so the UFO has landed. Let's see what happens. So now if I run it, it says, help me, I've been captured by aliens. All right, so that seems to work. So we know that will happen. Here they actually give you the entire program, just trying to show you how you can do that. What I would like to do is a couple of additional pieces. So it will grade it, but this hashtag means this, whatever's in a hashtag, doesn't get used by the program. The program just ignores it. So it's a help feature. So I'd like to make sure that you always put your name in there, just as a standard set of operations. You're always used to doing that. And you can put anything inside of these hashtags. All right. So it's automatically saving it into the Cengage piece, and we can actually say, all right, we know what we want, and we would like it to look like this. Enter the width, enter the height, and give us an area of whatever we look at. So, a lot of programs, we have to do a lot of assignments to say, hey, I'm going to use a variable. I have to say, I need a variable named this, and this is what it is. Python is really nice. It doesn't care. It says, here's a variable. You can put data, you can put text, you can put whatever in me. I don't care. So in this case, we're defining a variable on the fly called width. And we're going to use that assignment operator. And we're going to use the input. So we're going to input in, enter the width. And notice I put that space in there. That space will hopefully spread that out a little bit. Now, what I didn't do is I didn't put that int in there, because it's really the same thing. So I'm nesting them together. So I could also say width, and notice down here, as soon as I start typing, it actually gives me, hey, do we want to use that? Equals the integer of width. So we're just shortcutting it up here. So I'll show you the other way we could do it when we do height. So height equals, and so now we have two parentheses because we've nested those in together. Enter the height. Alright, so then we've done both steps together. So now both of those values, so both width and height, are both now set up as integers. So if I want to multiply or do something else, so now I create a new variable called area equals width times height. And then I'm going to print out. And notice I can split this up a little bit. So the area is, and when I put a comma in there, it says, all right, now we're going to have more content. Area, comma, square units. So we've got an input, we've got an input. We multiplied those two together and got us an area, and we've got an output called square units. So I'm going to run this and see what happens. So enter the width, 10, 20. The area is 200 square units. Well, that seems to work. Now, let me see if I can break it. Enter the width, 10.5. Oh, crap. So why did 10.5 break my program? It is. It's a decimal. It's a float. And we tried to put it in there. And we haven't seen a lot of pieces yet to fix that. So, for now, what I would probably do is come up on the top and put an instruction. So I'd probably do a print and hope people did the right thing and say, please input only whole numbers. Alright, so we solved our problem in one way. Alright, so we're going to run it, and I'm going to put 25, 74, or whatever I type. So that actually works really well. Now, again, we can break it, and you'll see those tracebacks, because if we don't input something that is truly a value that we're looking for. So we'll get to eventually how to solve some of those issues. So let me show you on this also what is really a good practice. A lot of people don't do it, and Python doesn't require you to do it. But in most languages, is my area declaring variables. So in most languages, you declare a variable, what type it is, etc. What I like to do in Python, and maybe it's just my own preferences, is I'm always paranoid about, is there something already in that variable space? So we have all those cells where data lands. Is there something accidentally in there? And so I tend to do this. I tend to clear them out, and I will do things like this. So I will say width equals 0. So what that does is called a garbage collection. It says, hey, you've got this variable, and it's going to always have that garbage cleared out. So I would probably do width, I would do height, and I would do area. So by putting in those zeros, what it does is says if there is a value in there, it automatically clears that out. And then I might come down here and I'm going to say this is my main program. Enter my width. It doesn't hurt anything. What it does is just make sure that there isn't a value in there. Now, when I'm testing this program, I can also do some other things. So I think that there's a problem with this statement, so I'm going to take it out. And by putting in that hashtag in there, I can take out this line. Notice it goes gray. And so now if I run this code, it says enter my height. Okay. The area is 0 square units. Oh, because I set the width up here to 0, and down here I took out the ability for that to change. So you can do a lot of testing with those asterisks or the hashtags also. And sometimes we even put in things like end of program. And sometimes we do that because we might take this code section and we might run it in something else. So now I'm going to go over here and take a look at the grade for this and see if this is the correct grade. So just doing this and running it doesn't submit it. And so I've had some students before look at that a little weird. So if I go to tasks, it'll give me all, so it'll say test case, test case, test case. So this is what it's looking for. So it's going to try to input 2 and 5, 5 and 5, blah, blah, blah. So I'm going to run these checks first. I'm going to say, oh, hey, it said I got all 3 of the checks correct. So I'm going to click submit. And now in my grade book, there will be 100% for that grade. Perfect. So I have to go to the tasks area, and I want to confirm and check before I do anything. I can check all the way through here. So if I have this missing, let's see what happens. So I want to run checks, and it should error out on part of it. It says, oh, no, it didn't pass any of them because none of them had a width and a height. So I simply take that back out. Now I run it again. So I can check those unlimited numbers of times before I actually submit. Other pieces here we can look at. You can see how many minutes we spent, how many key presses, if you copied and pasted. You mean I can see if you copy and pasted? Yes. Yes, I can. All right. So that's exercise 1-4. And we actually have 2 left then. And I think we'll tackle those then on Thursday to look at the last 2, and then there'll be a quiz for this particular week. All right. Any questions, guys?
Do the spaces matter?
Do space? Okay.
Because I noticed you'll type something and space equal space, put them on top where you cleared the variables, you didn't have any space.
Okay, so spaces and indenting do matter in Python. So Python, we haven't got to this part yet where things are indented, but let me show you what happens if I do an indent. So if I do this indent, it's going to hurry and say, oh, indentation error. So you have to be careful about your indents. In some places, spaces matter. In some, they don't. So let's see what happens if I take them out here and see if this actually runs. So in this case, it doesn't matter. I like them there just so I can see what's going on a little better. The other place that spaces matter or make it easier is notice inside of my quote marks. So I put a space in right here inside of it. And that space stays because that string is all captured by the quote marks. And that says when I enter the width, it leaves that space. So if I didn't put it there, well, in fact, let me just do this one and I'll show you. Because it looks ugly. So enter the width. And then I type a number, and notice how it's just shoved right in there and it looks kind of ugly. So that's why we do that inside of here. In fact, you may see in places like this, where we have the area is blank square units, you may find that we actually put in just a space at some points. And we'll show you some other tools to move data around. But the space is in here. Now because it's locked in here, it's going to add that space between area and square units. Does that answer your question? Does that make sense? All right. The last two, and then there's a quiz this week. So we started out kind of slow to let everybody make sure, A, I know a lot of people haven't got Cengage or for whatever reason, and B, we want to start out and not scare everybody the first couple things. So we only have these this week to do. Remember, there is the discussion board. There's a second discussion board for week 2. But we're starting out kind of on the slow pace to make sure everybody can get into Cengage. I will also say I'm a little gun shy after last semester and some Cengage issues, so we're checking to see if any of those pop up again. So for this week, the 1.1 through 1.7 are due, although there's a couple of those that are really just practice. But and then down here there's this reviewing the quiz basics, and then the discussion board. So that's what's actually due in the first week here. Next week, we're going to show you how to install Python, a way to do it, the idle environment on your own computer. So you'll be able to do this not just inside of Cengage, but actually on your own tool. So you'll be able to run at any point. Apparently, I haven't actually installed it on this one yet, though. So we'll show you how to do those kinds of things. So, any other questions? Going once, going twice.